Hello, good afternoon once again. Hello, Sir Jake Poperada, my teacher, and also my classmates for the software engineering subject. And today's video, I'm going to report my activity 4, which is the title Software Maintenance and Evolution. Okay, so without further ado, let's start. We're gonna go to the second slide. Here we have the topic outline, which includes number one, the introduction. We also have the brief history, importance of software engineering and evolution in software engineering. We have the applications of software maintenance and evolution in software development. And last but not the least is the conclusion of the overall report. Okay, so let's go to the introduction. So, software maintenance and evolution is the ongoing process of adapting and improving software through its life cycle to meet changing user needs, technological advancement, and involving business requirements. So, it doesn't stop where you have successfully created the system. Just like a waterfall, even if it's already reached the destination, you need to have changes. Example, if the management have new departments, you have new users, the cultures, and so on and so forth. You need to adapt to it in order for your system to work as intended. Okay, unlike static entities, software system evolves strategically, ensuring their relevance, resilience, and security. Okay, because the higher the hacker evolves, we also the engineers must improve as well. Okay, so this concept encompasses iterative development lifecycle, user feedback integration. Okay, that is important also, that we know what user thinks, what user wants, we should give them that. And next is the technology upgrade. Okay, if we upgrade our server, if we add new modules to the website that you are creating, we also need to have maintenance on it and risk management, so aiming to sustain the software's value and effectiveness over time. So in this exploration, we'll delve into the key principles and consideration essential for navigating the dynamic landscape of software maintenance evolution. Okay, let's move on now to the next slide. So we are now on the brief history of the software maintenance. So in the year 1950s to 1960s, this is the pioneering years. So this is where it started. So 1950s, the emergence of the first generation of computers marked the initial steps in software development. Maintenance was primarily focused on the hardware related issues, because on that year there is not yet any softwares that available in the market. All we have is the manual systems, manual hardwares that we use on our companies. Okay, but later on, after 10 years, we are now in the 1960s. The advent of high-level programming languages lead to increased software complexity. Okay, basic maintenance involves bug fixes and addressing hardware deficiencies. Okay, so in the year 1970s to 1980s, we are now on the structured programming and growth. Okay, in the 1970s, structured programming methodologies gained popularity. So it influenced the software design and maintenance, debugging tools, and version control systems, such as what we are using right now. We are using Git, and it was introduced in that year, 1970s. So after 10 years, we are now in the 1980s. The growth of the software industry brought attention to the need for more systematic maintenance processes, meaning we are following such path, such what do you call that, guide on how to maintain certain system. Okay, configuration management and documentation practice were improved. Okay, on the next year, we are now on the 1990s. It is the rise of the object-oriented programming. Okay, so adaptation of OOP influenced modularization and collaboration. So when we say OOP, it's about creating a system that can be modularized, meaning other systems which require that can use that kind of chunk of code into one another. So the usability is really high and reusable as well. So using OOP can make the software development agile, or we can have prototype in less than time, right? Because we don't need to reinvent the wheel. So that's the essence of the OOP as I have been taught, right? So it's focused on code reuse, meaning you don't need to write if you already written that, right? Okay, just like on a wheel, you already created that the wheel is circle. Why bother creating new type of shape if that is the best that we can have, right? And version control system like Git, we can turn back time where the code is on the version 1, 2, or 3 if you want to change path from inverted display into its regular display, or remove the um, certain anything on the system that you want to remove or to revert back to, and that's it. So we moved on to the 2000s, the agile paradigm shift. So agile methodologies emphasize flexibility and iterative development, meaning you need to have a system right away. You can have a prototype, you can create a system. And next is the maintenance adapted to changing requirements and prioritize user feedback. So we are now in the 2010. It is the creation of the cloud and development operations integration. That's what my report last week is all about. It's about cloud computing impacted development strategies, and DevOps streamlined collaboration, shaping maintenance process from the developers onto the operations. And that's it. In the year 2020s, the tech advancement and automation, with the continued DevOps emphasis with increased automation, maintenance evolved, addressing security legacy systems and emerging technologies that we are currently using right now. Okay? So next, we will go to the next slide, the importance of software maintenance and evolution in software engineering. Okay? We have here the sustaining software relevance. Ensures the software remains relevant by adapting to changing user needs, business requirements, and technological advancement. Meaning, if you added the department on your system, the system may need to adapt as well in order to be relevant, right? And next is the bug fixing and issue resolution. So addresses bugs and issue promptly, enhancing user reliability and performance. Next is adapting to changing requirements. If there are requirements that need to be removed, we need also to remove that in our system. So allow software to adapt to evolving requirements, preventing obsolescence, and aligning with current business objectives. If your system does not into the business objective, we need also to change that, right? In order to be relevant. And next is enhancing software functionality. It's all about how system works. And it involves perfect maintenance, adding new features, and improvements to enhance overall functionality, right? So go on to the next slide. We have here the optimizing performance. It doesn't mean that once you already created your system, so that's it. We need to calculate how the system responds. Like if it responds 10 seconds, we need to find a way to make it like 8, 7, or maybe half 5 seconds. So it will improve the work of the users. So it identifies and addresses performance bottleneck, inefficient code, and factors affecting software efficiency. So next is the most important, the security maintenance. Regular updates address security vulnerabilities, protecting against emerging threats and ensuring data integrity. Next is user feedback integration. Incorporates user feedback leading to a more user-centric software experience through iterative development. and last but not the least of the importance, involves updating software to leverage new technologies, ensuring compatibility with updated operating system, and adapting best practices. And let's move on now to the next slide. We are now on the applications of software maintenance and evolution in the software development. Okay, where can I use that? Where can we use that? So number one, we can use that in legacy system upkeep. Maintains and updates legacy systems, ensuring compatibility with modern technologies. Next is feature enhancement. How can you enhance your system to be more elegant or optimized in users? So add new features and improvements to meet changing user requirements and enhance overall software functionalities. Number three, we have here a bug fixing and issue resolution. Addresses software bugs promptly to ensure a stable and error-free user experience. Now, next is the security update. This is one of the important. Regularly update software to address security vulnerabilities, protect against potential risks. Okay, let's go on to the next slide. Okay, so performance optimization identifies and address performance bottlenecks, improving software efficiency and user experience. User-centric iterative development, what does it say? It integrates user feedback into development cycles, ensuring the software aligns with the user expectation and its needs. Number three, technology adaptation and integration. Facilitate the adaptation of new technologies, ensuring that the software remains current and takes advantage of technological advancements. And last is the risk mitigation. Identifies and mitigate risks associated with software, including security risks, data loss, and disruption in operation. Okay, so let's move on now to the last slide. So we are now on the conclusion. So in my summary, the dynamic domain of the software development, the pivotal role of software maintenance and evolution are evident. So legacy system upkeep ensures the adaptability and compatibility of existing systems. Feature enhancements respond agilely to evolving user needs, ensuring sustained satisfaction. Swift bug fixes, security updates, and performance optimization collectively fortify the reliability and efficiency of the software. And user-centric iterative development, technology advantage, risk mitigation further contribute to the software adaptability and resilience as indefensible cornerstone. These practices navigate the ever-changing software landscape, guaranteeing enduring high-quality solution. Okay, so that is all of my activity 4. I hope you learned something about it. If you have any question or suggestion, you can leave the comment at the box down below. And thank you so much for watching. I hope you learned so much from it, and see you guys soon. Have a great day. Bye guys. Goodbye.